Hey guys, welcome back. For today's video, we are going to be controlling a server motor via Bluetooth. We are going to use some information we learned in the previous video. You can click on the link here on the screen to go watch the video, or on the video banner on the screen to watch the video. So let's get right into it. But first, what is a servo motor? In simple short terms, servo motor just is basically a motor that can move in angle. So it moves in angle. So I can set the servo motor to go to 90 degrees, but go to 180 degrees, but go to 10 degrees. So the servo motor using here is the SG90 servo motor. So it's guaranteed from 0 to 180 degrees. Let's take a look at it on Chrome. So this is the SG90 servo motors. The other servo motors are actually in the same format. So for the pinout of the servo, I have the red wire is the 5-volt supply, the brown wire is the ground, and orange is PWM. That is to go to your microcontroller pin. So now let's go to our code. But before we jump into our code, I'm going to show you a new application that allows us to control our servo motor easily. So we'll not be using a Bluetooth terminal this time. We'll be using a different app called Bluetooth Electronics. It's by CoolSoft. So let's open that up. So let's go to my phone. This is the app over here. So we no longer be using this app. We're using Bluetooth Electronics. So I click on it. Now it's open. So to connect to our Bluetooth device, we click connect. Then select Bluetooth Classic. Next. Then we choose this ESP32 here, or whatever you name ESP32. So mine is named ESP32 BT Slave. Remember what I said about slave? With slave device, it means that another device has to connect to it. If the device was a master, it will have to connect to a slave device. So let's click connect. Now it's connected. Done. So we come to look for any empty box here. Let's choose this empty box and click edit. So we'll come to sliders. We want to control our servo motor. We click on this slider and drag into the screen. We want to edit the slider. So we want ourselves to go from 0 to 180, but let's put about 179. But we don't want to go to 180. So when it's sending the value from 0 to 180, so start with console. So start with a G. So I'm going to send G plus the value and A. So anytime I say G, I know I'm sending several coordinates or several angles. I'm going to end it at A, but we're not really bothered about the A. So now we're done with our setup. I've set the minimum to 0 and maximum to 179. So we go back. Oh, we didn't connect, so let's connect again. That's connected. Connect. So it's connected now. So I have to come and click run. So now I'm going to open my webcam so you can see the servo. The servo motor is here. So open my webcam now. You can see the servo motor. Now watch what happens to it as I move the slider. All right, so now let's go to the code. First thing, added some new things to the code. So the code is basically the same code used in the previous video. Added some new things, which is the ESP32 servo library. So you can just search for that in the Arduino library. You just come here and search for ESP32 servo. This is ESP32 servo by Kevin. So you install that. And so I name my servo and gripper. So when I want to create a servo object, I have a servo, this servo is like the class. So I want to create an instance of that class, which is gripper. It's basically an object of servo. So if I have more than one servo, I have to create more. Let me share an example. So I just come here. Servo, let's call it something else. Let's call it base. If I want to create more and more, so I'm using more and more servos. I just repeat it multiple times for the different servos, but I have to give them different names, and the names are case sensitive. So now here I define the pin I want to use for my servo motor. So I said as define S113. I just name this. What I do is create a variable where I store the value 13 in. So I'm storing 13 in S1. Mean anytime I call S1, it means I'm calling pin 13. So I've explained most of this in the previous video. Yes, this is new. So now, no, this is not new. What is new is this char Bluetooth data. So the char is basically the data type in C++ that holds characters. By characters, I mean a character, literally. So like A, B, C, D, just one letter. That's, I mean, if you can hold a percent sign or one letter, just one character, a char. So back in our voice setup, the only new thing in our voice setup is this, which is gripper.attach. And I'm going to attach our servo, which I named gripper. If you remember your servo gripper, I'm going to attach it to S1, and S1 is pin 13. So in our void loop, this part remains the same. The only thing that changes is in when we receive Bluetooth data from our mobile phone. So here, I equate this by Bluetooth data we created earlier, which is a char, to serial BT.read. This means that whatever I read on the Bluetooth, it writes to the Bluetooth data, and I print out the Bluetooth data to serial monitor. That's why I can see all these values print on the serial monitor. So you print the G, then the angle, then A. Remember we saw on the app, it was G plus the value plus A. Then I print the Bluetooth data to the serial monitor. I said that already. Then remember the first character I said is G. Remember it's G plus 125 plus A. So I check if I see the character G. As I do this, if Bluetooth data equals G. So when you see two equal to signs together, I mean you're doing comparison. So if it's G, I create another variable, an integer variable. That's why I did this int over here. Int angle. So it reads the Bluetooth data or passes that data as an int. That's why you see pass int. By int, I mean integer. So it passes the data as an int. What does it converts the data to an integer, meaning that anything that an integer is going to ignore it. So remember we're getting G 125 and A, like G plus 125 and A. G and A are not integers, so it's going to ignore them and just take the 125. The angle now becomes 125. And I tell my servo, which I named here, gripper. Remember I named servo gripper. So the name here is gripper. Now gripper.write, the angle which is 125. Then the servo moves to that particular angle. And just print the angle on serial monitor so you can see it. So that's basically how the whole thing works. If you are controlling more than one servo, just to repeat the same thing. So let's quickly just run through what we're going to do for controlling more than one servo. I said earlier, we just do something here like this. The name is one base. Base will create. Let's copy this guy too. I'm going to name it S2. Let's give it a different pin. What pin can I have? It's pin 9. So we'll come here and do base.attach. Right, let's use 26. There are some pins that we can use on ESP32. I'm going to attach a link in the description to random tutorial where I explain the pins you can use for ESP32 and the pins you can't use. So I remember 26 is a good pin to use. So let's continue. Now I've done base.attach and I type in S2. So I just come here, copy this. Let's say now for the base, I'm going to send character B. So now back in the app, what I'm going to do now is to create another slider as we did earlier. Then you should start with the letter B, small letter B, and that's all. So when you connect, you cannot control the second servo motor that's connected to pin 26. If you want to control the third servo motor, repeat the same thing. If you want to control 4 servo motors, repeat the same thing for the 4 servo motors. And that's all. Thank you guys for watching. Please do not forget to subscribe, and if you think this video is useful to anybody else, your friends, anyone, please share to them. Yeah? See you guys in the next video. Bye.